In lower secondary, we have learned that the gradient of a line is a measure of how steep the line is. It is the ratio of the vertical change to the horizontal change. Or for many of us, we know it as gradient essentially is the rise over run. In mathematics, we have also learned the formula to calculate the gradient of line segment, stating the formula as y1 minus y2 over x1 minus x2. In this section, we will explore the relationship between the gradient of a line and the angle of inclination, or for that matter, using trigonometry to make sense with the gradient of the line. Let us look at this line drawn on a Cartesian coordinate. Allow me to pick out 2 points and show you how to calculate the gradient. Let me call this A, and by writing its coordinates, I know A is 1, 3. Let me choose this other point, all right, and call it B. The coordinates of this point essentially is -2, 0. If I were to calculate the gradient of AB using my lower sec knowledge of rise over run, I can see that my gradient of AB is the same as my rise, which is 3 units, over my run. It has run 1 unit, 2 units, 3 units, over 3. And because this is, you see that the slope is in an increasing manner, you get a positive, so that's gradient of AB equals to 1. Other than using the rise over run concept, we can calculate if I call this as set 1 and I call this set 2, I know that gradient of AB can be calculated by taking y1 minus y2 over x1, the x-coordinate of the first set, minus the x-coordinate of the second set, which essentially is 3 over 3, which gives you 1. Now, if I look at this right angle triangle that is formed, A, B, let me call this coordinate C. Let me call this point C. If I look at this right angle triangle, and I have an acute angle over here, right, an acute angle over here, and call it theta. Now, in respect to the angle theta, if I talk about the rise is actually the same as in trigonometry what we call as the opposite side with respect to the angle theta. With respect to the angle theta, we also know that BC is actually the adjacent side of the triangle with respect to angle theta. If I were to link this opposite and adjacent together in a right angle triangle using my trigonometry, I will know that tangent theta essentially is opposite over adjacent, all right, of which opposite side is actually the rise, and the adjacent side is essentially the run. With this in mind, we can therefore conclude that a gradient of line segment can also be calculated by using tangent theta. Now in lower level, we also learn about acute angle as well as obtuse angle. When we calculate angle, we start from the first quadrant and then we move to the second quadrant, third and fourth if it is applicable. We know that if I have an acute angle called theta, if I have sine theta, it is the same as doing sine 180 degree minus theta. We know that cosine theta, if theta is acute, is essentially the negative cosine of the obtuse angle here. Same goes, tangent theta is the negative tangent 180 minus theta. We know that this happens when an angle is obtuse, meaning 90 degree 280 degree. Now, if I have an angle that is obtuse, all right, if I have an angle that is obtuse, it will then add up with another acute angle to form 180 degrees. All right, when we read angles, this is obtuse, this is acute. Let us calculate using tangent theta. If I choose 2 points again, maybe this time round, let me choose, say, this point versus this point. All right, let me call this point P, let me call this point Q. P is negative 2, 4. Q is 2, 0. All right, to calculate tangent theta in this case, this is my right angle triangle. All right, to calculate, maybe I shouldn't call it theta this time round. Let me call it beta. All right. Sorry, this is beta. This is 180 minus beta. We know that to calculate tangent beta, it is the same as writing negative tangent 180 degree minus beta. If I look at tangent of this, with this angle here that is shaded in red, this is the opposite side, this is the adjacent side. We can therefore conclude that tangent 180 minus beta, this angle here will be the opposite, which is also the rise, that's 4 units, over the horizontal, which is change in 1, 2, 3, 4, 4 units as well. So that will give me negative 1. All right. If we use our calculation, all right, if we use our calculation, gradient of line PQ. All right, let me call this set 1. Let me call this set 2. So I will have y1, the y coordinate of set 1, minus away the y coordinate of the second set, over the x coordinate of the first set, minus away the x coordinate of the second set. This will give me 4 divided by negative 4, which is also negative 1. So what can I conclude here? To link trigo and gradient together, essentially, the gradient of line segment is still tangent of the angle form. All right, I thought I'll use this segment, a short video, to share with you the relationship between trigonometry as well as gradient. Let us proceed to the next segment.